Welcome to this edition of Marjoram and Marshall Academy. We ask that you please refrain from talking in order to be respectful to all of our patrons. Also, please hold your questions till the end of the viewing. Thank you and enjoy the show. Today we're going to be talking about inequalities. You probably know a little about inequalities even if you think you don't. Inequalities have to do with these symbols right here. And of course, the equal sign. Obviously the first symbol would be the less than symbol. The second symbol would be the greater than symbol. And the third symbol would be the equal sign, which we all should be very familiar with. If we look at an example here, we usually use these symbols when comparing numbers. Let's take the numbers 9 and 13. Now, if I were to put one of these symbols in here, I'm pretty sure most of you could tell me what symbol that would be. What we would do is we also know that it always eats the bigger number. So it would be 9 is less than 13. What I want to do now is introduce some new symbols that you maybe haven't seen before. First symbol we'll use is less than or equal to. It actually looks like half of an equal sign on the bottom, where this line is, and then it has the less than symbol on the top. The other version of that would obviously be greater than or equal to. And let's go ahead and do a few examples using these symbols. For example, if we have the number 10 and the number 15, and we want to use one of these symbols to describe the relationship between these two numbers, we could say that 10 is less than or equal to 15, because this statement is true because 10 is less than 15. This statement would also be true if we had 15 and 15 and use the same symbol, because we're saying that this number is less than or equal to. So less than or equal to 15. Okay, now we're going to throw a variable in the mix. We're going to use the letter x, like we usually do when we're talking about variables. The equation says x is less than or equal to 2. And what the question asks us is which numbers make this statement true, or make the inequality true. They give us numbers here. We got the numbers -3, 0, 2, and 4. Basically what we're going to be doing here is plugging in each of these numbers for x and seeing which numbers make our equation true. So first one we have is -3, and we say is -3 less than or equal to +2? Well, we know that that one is true because -3 is less than 2, so that would mean it is also less than or equal to 2. Next we'd plug in 0 for x, so we have 0 is less than or equal to 2. We also know that that is true because 0 is less than 2. Next we look at 2 is less than or equal to 2. Well, we have to think about what this is asking. It's not just asking less than, it's asking less than or equal to, and 2 is equal to 2, so that is also true. Now we look at our last one. It says 4 is less than or equal to 2, and we have to think about this. Is 4 less than 2? Well, 4 is not less than 2. Is 4 equal to 2? And 4 is not equal to 2 either, so we've canceled both of those out. So this statement is actually false. Okay, the next thing we're going to look at is actually graphing these type of inequalities. We have n is greater than or equal to -3. If we look down here at this sad excuse for a number line, this crooked looking number line down here, we find -3 on our number line, and what we're going to do, since it's also equal to -3, is we're going to color this in. And let me change colors real quick so we can actually see what's going on here. So we'll color in this circle on -3, and now think about which direction I'm going to go to include the rest of the numbers that fit this equation. If n is greater than -3, I'm going to obviously go to the right, and my numbers will continue on from there, so I make sure to draw my arrow to show that these numbers will continue, because this is everything equal to and greater than -3. Here in a second I'll try to draw a better number line, and we'll figure out what happens if it's just greater than instead of greater than or equal to. We'll look at the difference. Alright, now we changed it up a little bit. Using the same number, we're still using -3. If you remember when we just did greater than or equal to -3, we colored in the dot on -3 on our number line and drew our arrow to the right. Now on this one, the difference is, since it's not greater than or equal to, -3 will not be included, because n has to be greater than -3, not greater than or equal to. So there has to be a way we can make this a little bit different than our greater than or equal to sign. And the way we can do that is, instead of drawing our filled in dot like we did for the greater than or equal to, and we also would do that if we had a less than or equal to. So we always fill in our dot. Instead, we will be having an open dot. You can kind of imagine this, since -3 is not included. He's at the party with the rest of these numbers, but he's not included in all the fun, so he doesn't get his glass of fruit punch filled. But if he was included with the equal to, then he would get his fruit punch. And sorry, I just completely screwed up that circle. So if we look at our number line here, he has no fruit punch in his glass because he's not included in this equation. So we draw an open circle, and we still draw our same line all the way down, and that includes all the values that are greater than -3. I hope you enjoyed our presentation today about inequalities. Mr. Marjoram and Mr. Marshall will not be signing autographs today after class. I'm sorry. You're more than welcome to tell them how awesome they are on your way out of class today. Now would be the best time to raise your hand and ask questions if there's anything that confused you during the video, or any general questions you have over inequalities. Thank you, and good job today.